Welcome back to a new session of MOOC on information security. Today we will discuss the overview of symmetric key algorithms. The objectives of this module are to get an overview of the various symmetric key algorithm and their features, to understand the characteristics of a good cipher, and to have an idea on the important encryption algorithms. We have already seen substitution and transposition methods which can be considered as the building blocks for encryption. Other techniques can be based on each of them or a combination of both of them. It is to be noted that each technique is only a part of the complex procedure to encrypt our valuable data. Just imagine a situation that your car is locked and kept inside a locked garage. So, a combination of various techniques is needed to strengthen the overall security of the system. A combination of two ciphers is called a product cipher. Product ciphers are normally performed one after the other. Just applying two ciphers does not mean that the result is stronger than or even strong as either individual cipher. So far we have discussed different techniques and also examined the approaches used by cryptanalysts to attack the encryption algorithm. Now let's see some characteristics that make a secure encryption algorithm. Secure encryption algorithm. There are many kinds of encryption including different techniques, but the selection of an encryption algorithm depends on the application. We have learned two broad classes of algorithm such as substitution and transposition. Substitution hides the letters of the plain text while transposition scrambles the letters. In 1949, Claude Shannon, an American mathematician and cryptographer popularly known as father of information theory, proposed several characteristics that identify a good cipher. Some of them are: the amount of secrecy needed should determine the amount of labor appropriate for the encryption and decryption. The set of keys and the enciphering algorithm should be free from complexity. The implementation of the process should be as simple as possible. Errors in ciphering should not propagate and cause corruption of further information in the message. The size of the enciphered text should be no longer than the text of original message. Symmetric key encryption. You may not be aware that symmetric encryption is in use just about everywhere you look. It's part of secure online banking to online purchase and delivery. As we have seen earlier, symmetric encryption is a type of encryption that uses the same key to encrypt and decrypt data. Both the sender and the recipient have identical copies of the key, which they keep secret and don't share with anyone. This differs from asymmetric encryption, which uses two keys: a public key that anyone can access to encrypt information, and a private key which is kept secret with the recipient to decrypt information. In general, the working strategy of encryption is: the sender uses an encryption key, usually a string of letters and numbers, to encrypt their message. The encrypted message, called the ciphertext, looks like scrambled letters and can't be read by anyone along the way. The recipient uses a decryption key to transform the ciphertext back into readable text. In the example shown here, we use the same key for encryption and decryption, which means this is symmetric encryption. Here, only sender and recipient can read and access the data. This is why it is also sometimes called secret key encryption, secret key cryptography, private key cryptography, and symmetric cryptography. The figure shown here illustrates the basic concept of how symmetric key encryption works. Two identical keys encrypt and decrypt data. Having only one key to serve both encryption and decryption functions simplifies the encryption process. After all, you are applying one key to turn plain text readable information into unreadable ciphertext and vice versa. One of the advantages of using symmetric encryption is that it provides data privacy and confidentiality without the extra complexity of multiple keys. Symmetric key encryption is useful for encrypting databases and files where we are not supposed to exchange data publicly between parties. But there is an overhead in technical process such as key distribution and management issues. History of symmetric key encryption. The use of symmetric key encryption to encode digital data through the use of computers has been started around the mid of 1900s. But the concept behind it's created thousands of years ago. The best known example of symmetric encryption is symmetric cipher, which is credited to the Roman general Julius Caesar and is known as the Caesar cipher. However, there have been other types of symmetric ciphers that have existed throughout history, including everything from the Vigenère cipher to the modern AES algorithm. Symmetric key encryption is a method to pass a message securely in which only you and your intended recipient can read it. Apart from this type of encryption, there is another one that is close in name but is different in terms of what it does: asymmetric encryption. We mentioned this name many times, but just know that asymmetric encryption is what makes it possible to authenticate and exchange symmetric keys through public networks such as the internet. Now we are trying to explore the inner details of symmetric key encryption. Working of symmetric encryption. It's time to take a closer look at the symmetric encryption process. To understand how symmetric cryptography works, you need to know what are the components involved in the process. First of all, the plain text, which is the original message you wish to encrypt. It should have a symmetric key encryption algorithm and an identical secret key that is possessed by only you and your intended recipient, which can be used to encrypt and decrypt the data. And the ciphertext, that is the encrypted message that no one else can read. The way that symmetric encryption works is by encrypting and decrypting data through the use of identical keys. The data, once encrypted into ciphertext, cannot be read or understood by anyone who doesn't have the key. To better understand how symmetric encryption works and how all of these components work together, you can refer the Caesar cipher we have covered in one of the previous modules. Caesar cipher or shift cipher was a method by which Caesar was able to secretly communicate with his generals without anyone being able to read the messages. In this case, a cipher is a number of sequences of steps that you would use to convert plain text information into unreadable ciphertext. With a basic shift cipher, you can encrypt and decrypt a message simply by shifting the message along the alphabet a set number of spaces. An illustration of how a shift cipher works is given in the figure. Imagine writing out the entire alphabet in a single long line. And when you use the shift cipher, you shift any given letter X number of spaces. So, if you were to shift the letter H by 9 spaces, it would become Q. The letter P would become Y. This means that the message good morning becomes PXXM VXA WRWP when you shift each letter 9 spaces to the right. So, the key in a Caesar cipher is the secret value that only you and your recipient know, which tells you how many letters to shift. Nowadays, most of the information exchanges take place through virtual channels, through computers, websites and mobile phones, and the internet in general. And while the internet makes things amazingly convenient, banking online or paying for grocery over the internet doesn't come without its risk. The role of symmetric key encryption in website security. Symmetric key encryption is part of the public key infrastructure or PKI ecosystem, which makes it possible to communicate securely across the insecure internet by converting plain text or the readable data into unrecognizable ciphertext. We'll discuss the PKI in detail in the coming modules. Symmetric encryption algorithms. Symmetric algorithms are broken down into two main types, the stream and block ciphers. Block ciphers encrypt data in chunks or blocks, whereas stream cipher encrypt data one bit at a time. Now let's see the most commonly used symmetric algorithms. Data encryption standard or DES. DES is a type of block cipher that encrypts data in 64-bit blocks and using a single key that is one of three sizes: 64-bit, 128-bit and 192-bit keys. However, one of every 8 bits is a parity bit, meaning that a single length key that 64 bits is really like using a 56-bit key. Although DES is one of the earliest symmetric encryption algorithms, it's viewed as insecure and has been deprecated. Triple Data Encryption Standard TDEA or 3DES. Unlike DES, triple DES can use 2 or 3 keys, which enables this algorithm to use multiple rounds of encryption. While 3DES is more secure than its DES predecessor, it's not as secure as its successor AES. Advanced Encryption Standard or AES. This encryption algorithm is what you will most commonly find its use across the internet. The Advanced Encryption Standard is more secure and efficient than DES and triple DES, with key options that are 128 bits, 192 bits and 256 bits. However, while it's also a type of block cipher, it operates differently than DES and triple DES because it is based on a substitution permutation network. We'll cover these DES and AES algorithms in detail later, and for the time being, let's check some differences between block and stream ciphers in the coming weeks in additional articles. But for now, let's move on to discussing the secret in secret key encryption. The most important thing for symmetric encryption to work, however, is to keep the key as a secret. Otherwise, if someone else knows the key, then they can decrypt your data and read it, which makes the entire encryption process pointless. That's why it's vital to keep the secret key secret and away from prying eyes to limit the number of people who have the key. As such, you should never store secret or private keys in any internet-facing environment. Applications of symmetric encryption in our daily life. Symmetric encryption is useful in many cases and has implementation opportunities across various industries. For example, symmetric encryption is useful for encrypting banking-related data as well as data storage. Banking. Have you ever heard of PCI DSS? The Payment Card Industry Data Security Standards is a set of 12 requirements that businesses or organizations that accept credit card payments must adhere to. Symmetric encryption is a key component of PCI compliance as it directly correlates to requirement number 3, which focuses on protecting at-rest cardholder data. This is different from requirement number 4, which focuses on protecting in-transit data. That's about using asymmetric encryption. Data at rest. Data at rest refers to the state of your data while it's residing on a server or a device. It is not in transit, meaning that it's not being sent across a network or the internet. So, consider the example of a private diary. You write either highly valuable or sensitive information in that you don't want anyone else to read. So, while you are not sending it anywhere, it doesn't mean that you want someone else to be able to read its contents if they manage to get it. So, at-rest data encryption is what prevents the type of exposure from happening. Many Google's G Suite services use at-rest data encryption in addition to in-transit encryption via HTTPS to secure your data. Understanding what symmetric key cryptography is and how symmetric encryption works is very important as we wish to protect our data from unauthorized access. This session provides you with some awareness that will help you better understand the process and its role in cybersecurity. Even though symmetric cryptography is an ancient method of encryption, it still holds an invaluable place in our digital world. The benefit of symmetric key encryption is that it is fast and convenient to set up. This method is simple and easy to understand, so anyone can easily master it. The single disadvantage is that the receiver must get the secret key from the sender. Hope you understand the topics discussed in this session. See you next time. Bye.